Hello students, today's video is on standard loci in Argand plane. Locus is very important topic of JEE and other entrance exams. This video covers the derivations, application and previous year questions. So watch till end. Now distance formula in terms of complex number. If P point is alpha 1, beta 1 and Q is alpha 2, beta 2. And in terms of complex number is this P is Z1 and Q is Z2. So PQ according to distance formula is alpha 2 minus alpha 1 whole square plus beta 2 minus beta 1 whole square. Where Z1 is alpha 1 plus iota B1 complex number and Z2 is here alpha 2 iota B2 beta 2 and Z2 minus Z1 is what how we derive subtract real from real part and imaginary from imaginary part. So Z2 minus Z1 is alpha 2 minus alpha 1 plus iota beta 2 minus beta 1 and its modulus is square of real part plus square of imaginary part. So what we conclude here that these two equations are same. So the distance PQ in terms of complex number can be expressed as Z2 minus Z1 whole mod. So distance formula here written as PQ Z2 minus Z1 whole mod, where Z2 minus Z1 is alpha 2 minus alpha 1 plus iota beta 2 minus beta 1 whole modulus, and its modulus is this. Now next. Now what is locus? Locus is the path traced by a moving point according to some given condition. Here if Z is variable point and Z1, Z2 are two fixed points in the Argand plane, and the condition that Z minus Z1 whole mod is equal to Z minus Z2 whole mod is what distance of Z from two fixed points Z1 and Z2 is same. Or in other words, locus of Z is a perpendicular bisector of the line segment joining Z1 and Z2. In this particular case, the point P, that is Z, and if I take A as Z1 and B as Z2, then this point P moves in such a way that the distance of this point P from A is equal to its distance from B. This point has to follow the condition that PA is equal to PB. If this point comes here by following the condition that PA is equal to PB. This comes here again by following the same condition that PA is equal to PB. This distance PA is equal to PB. Now the path traced by this moving point is what this, and if I trace this path, then this is always a perpendicular bisector of the line joining A and B. So whenever you get the condition that point is moving in such a way so that distance from two fixed point is always same, that is P is equal to PB, then locus is always the perpendicular bisector of the line segment joining the points A and B. And in terms of complex number, if P is Z, A is Z1 and B is Z2, I can express this as Z minus Z1 whole mod is equal to Z minus Z2 whole mod. Then locus of Z is always a perpendicular bisector. Same condition is written here. Now next. Now equation of circle. The equation of circle whose center is at point having fx z0 and radius r is mod of z minus z1 is equal to r. As we know that the definition of circle is the point P moves in such a way that that distance of this point from center is always constant. That means if this P comes here, the distance remains same. If P comes here, the distance, then the locus is a circle. That means we are following the condition that PC is equal to constant and that constant R. And in terms of complex number, this can be written as Z minus Z naught whole mod is equal to R, where Z naught, CZ naught is what? The center of the circle, and R is here radius of the circle. Now next, what is, if the center of the circle is at origin and radius R, that means we put here 0, what we get mod of Z is equal to R is what? The equation of is the locus Here locus is a circle with center at origin and radius r. If mod of z minus z naught is less than r, then this represents the position of a point. That means z minus z naught whole mod is less than r, then this represents the interior of the circle of z minus z naught whole mod is equal to r. But if mod of z minus z naught is greater than n, then this represents the exterior of the circle, z minus z naught whole mod is equal to r. Now here, if A and B are the extremities of diameter and P is the moving point, and if this P follows the condition that PA is perpendicular to PB, then if PA is perpendicular to PB, we can apply Pythagoras theorem. And as we know that this is what the condition of circle, if this point moves in such a way such that the the distance, the angle between P and PB is 90 degree. If this point comes here with the same condition, then the locus is always a circle because this is the property of circle. And since this is a right angle triangle, so after applying Pythagoras theorem, what we get, PA square plus PB square is equal to AB square. And in terms of complex number, since PA is mod of z minus z1 and PA square comes out to be here z minus z1 mod whole square, PB square comes out to be z minus z2 mod whole square, and AB square comes out to be z2 minus z1 mod whole square. So that means if this kind of condition is given to us, then locus of z is again a circle with z1 and z2 as the extremities of diameter. Now what is written here? Z minus z1 upon z minus z2 whole mod is equal to k. If this k is not equal to 1, then a locus is circle. But if k is equal to 1, then locus is a straight line. I'm just rewriting it. If mod of z minus z1 upon z minus z2 is equal to k, and suppose that k is 1, then as we know that in division mod can be break into two parts, that is mod of this can be broken into two parts, that mod of z minus z1 whole mod upon z minus z2 whole mod is equal to 1, and further I can write this as this. And what is this? This is what the locus of z is, a perpendicular bisector, so that is a straight line. But if mod of z minus z1 upon z minus z2 whole mod is equal to k, and that k is not equal to 1, that may be 2 or 1 by 2, and when we resolve this, we get, then here what we get, the locus of z is here a circle. Now here are the applications. The complex number z is equal to x plus iota y, where which satisfy this condition, z minus 5 iota upon z plus 5 iota whole mod is equal to 1, and we have to check, as we know, if this k is 1, then locus is straight line. So that may be the axis of x, or that may be the straight, because both a and b are straight lines. So we can neglect C and D because C is the circle with pass through 1 1, and parabola, D option is parabola whose vertex is 0 1. So we can neglect these two options. So my option may be A or maybe B. But further we have to check. So what we do, we just replace the z by x plus iota y and break this mod. So I just replace z by x plus iota y, and I just break this mod. On further solving, I get x and separate real and imaginary part. This goes here, and after separating real and imaginary part, I get this. And since we know that modulus is what, square of real part plus square of imaginary part. Same here, square of real part plus square of imaginary part. After squaring both the sides, we get x square plus y square plus 25 minus 10y is equal to x square plus y square plus 25 plus 10y. On further solving, what I get, 20y is equal to 0, and y is equal to 0, which is what? Equation of x-axis. So my correct option is here, option A. And this was asked on 2005 AIEEE exam. W is equal to, just we have to write all the given condition. W is equal to z upon z minus 1 by 3 iota. What next is given? Modulus of W is 1. And we have to find that z lies on one of the four options. So we just replace this W by z upon z minus 1 by 3 iota is equal to 1. As we know that if mod of z minus z1 upon z minus z2 whole mod is equal to 1, then locus is a straight line. So my correct option is here, a straight line. But if I have to find the equation, then I just replace z by x plus iota y and break the mod. That means I replace numerator by x plus iota y and denominator by x plus iota y minus 1 by 3 iota whole mod. And as we have done in my previous question, just take this to this side, separate real and imaginary part, and rest what we have to take the modulus and then squaring both the sides. So mod of left hand side is x square plus y square, and mod of right hand side is x square plus y minus 1 by 3 whole square. And after squaring, what we get, this is x square plus y square, x square plus y square plus 1 by 9 minus 2 by 3y. And on further solving, what I get, that my answer is y is equal to 1 by 6, which is what? A straight line, equation of a line parallel to, equation of line parallel to x-axis. So this is what the proper equation of the line, but since we just have to check whether this is an ellipse, circle, straight line or parabola, so we can directly take the option 3. Now here, what is given to us, that mod of z minus 2 upon z minus 3 is equal to 2. Represent a circle, because this k is not equal to 1, this k is 2, so obviously this is a circle, but we have to find radius of that circle. So just replace z by x plus iota y, separate real and imaginary part. I just take this to this side. This is x minus 2 plus iota y. This is x minus 3 plus iota y. After taking mod, this is x minus 2 whole square plus y square. Here I get x minus 3 whole square plus y square. Squaring both the sides, we get x square plus 4 minus 4x plus y square is equal to 4. X square plus 9 minus 6x plus y square. Further solving, we get x square plus y square minus 4x plus 4. On an RHS, I have 4x square plus 36 minus 24x plus 4y square. If I take this x square on RHS, I get 3x square. On taking this y square to RHS, I get 3y square. Minus 4x goes to right hand side, this comes out to be minus 20x, and if this goes on RHS, I get plus 32. Now this is not in standard form, so I divided by 3. What we get, x square plus y square minus 20 by 3x, and this is 32 by 3. On comparing this with the general equation of the circle, that is x square plus y square plus 2gx plus 2fy plus c is equal to 0. From this we get radius, formula for radius is g square plus f square minus c. So just on comparing the coefficient, that means 2g is here minus 20 by 3. So 2g is suppose minus 20 by 3, then g is here minus of 10 by 3. 2f is here 0, so my f is here 0, and c is here, comparing these two, we get c is here 32 by 3. Now I'm putting these value in formula of radius, I get this is 100 by 9 minus 32 by 3. On taking LCM, this is 100 minus 96 upon 3, and that is whole root of 4 by 9, that is 2 by 3. So my correct option is here. So radius of this circle is D part, that is 2 by 3. Now next, what is written here, that z minus 2 minus 3 iota whole square, z minus 4 minus 3 iota whole square is equal to lambda represent equation of circle. Since we know that z minus z1 whole square plus z minus z2 whole square is equal to z2 minus z1 whole square, the locus of Z is a circle where z1, z2 are the extremities or the end points of diameter. So I can just rewrite this as z minus 2 plus 3 iota whole square, z minus 4 plus 3 iota mod whole square is equal to lambda, and in place of lambda we have z2 minus z1 whole square. Now z1 is here 2 plus 3 iota, and suppose this is what the one of the vertex, one of the end of the diameter 2 comma 3. z2 is here 4 plus 3 iota, that is another end of the diameter, that is 4 3, and this lambda is at lambda is mod of z2 minus z1 whole square, or is what ab whole square, that is distance square of the distance AB square. It's what AB whole square. Now if either I can check Z2 minus Z1 and then take mod, or we can just check the distance. Now if I use distance formula, then distance between AB is, my AB is 4 minus 2 whole square, that is 2 square, and 3 minus 3 whole square, so distance AB is here 2, and AB square is here 4. So in this case my lambda is AB square, so that is 4. So my correct option is here option B. So lambda is here 4. Now next, what is written here? Now this is what an ellipse, x square by a square plus y square by b square equal to 1, where these a and a dash are the vertices, is what a0, and a dash is here minus a0, and s and s dash are foci. S is ae0 and s dash is minus ae0. And according to the definition of an ellipse is the set of all points in a plane, the sum of whose distances from two fixed points in the plane is constant. Ellipse is what the locus of a point P which moves in such a way so that sum of its distance from two fixed points are two foci, is always constant. That is, PS plus PS dash is always constant, and this constant is what length of major axis, that is distance between two foci, and that is here 2a. And distance between two foci, that is SS dash, is here distance between AE0 and minus AE0 is 2AE, and we can conclude that in ellipse the distance between two foci, that is SS dash, is less than the distance between two vertices, that is AA dash. So we know that here that SS dash is less than AA dash, and this 2A is what AA dash here, distance between two vertices. Now in terms of complex number, if this P is Z, S is here Z1 and S dash is here suppose Z2, then if I replace this, then what I get, thus PS is Z minus Z1 whole mod and PS dash is Z minus Z2 whole mod, and suppose this constant is here lambda. that is 2a. Then locus of z is ellipse if this lambda, that is 2a, is greater than the distance between z, this ss dash in terms of complex number is z2 minus z1 or z1 minus z2 whole mod, that is distance between two foci. So if z minus z1 whole mod plus z minus z2 whole mod is any constant lambda, and according to definition this constant is 2a, and this 2a is greater than, always greater than 2ae. So if this constant is greater than mod of z1 minus z2, then locus of z is an ellipse where s and s dash are foci and p is any point on ellipse and a is semi-major axis. So this is what locus in terms of complex number. But if this p point and this s dash is my z2 and s is my z1 and p is my z, and if suppose this ps plus ps dash is equal to ss dash, then in this case, if this is equal to this, then locus of z is a line segment joining z1 and z2 where z is lying in between s and s dash. So if this lambda is greater than mod of z1 minus z2, then locus is ellipse. But if this is equal to z1 minus z2 whole mod, then locus of z is a line segment joining the point z1 and z2 where z is in between z1 and z2. So this is what definition of ellipse. Now here is the application. If z minus z1 whole mod plus z minus z2 whole mod is equal to lambda, where z1 and z2 are fixed complex number, represent an ellipse, then my correct option is, as I know that this lambda should be greater than mod of z1 minus z2 whole mod. So my correct option is here B. Now look, another application, if z is a complex number in the Argand plane, then the equation that mod of z minus 2 plus mod of z plus 2 whole mod is equal to 8. I can just rewrite that this as z minus 2, z minus of minus 2 means my z1 is here 2 plus 0 iota and z2 is here my minus 2 plus 0 iota, and 2a is here my 8 and s is here my 0.20 and s dash is here minus 20. S is 20, S dash is minus 20, and SS dash is what distance between 20 and minus 2, that is 4, which is less than 8. So that means this is what locus of z is here, an ellipse, right? Because in ellipse, this z1 minus z2 is less than that constant lambda, which is 2a. Next. This is what an hyperbola, where this point is vertex, that is a0, this is another vertex, that is minus a0, and here this is my foci, one of the focus ae0, and s dash is another focus minus a0. And according to the definition, hyperbola is the set of all points in a plane, the difference of whose distances from two fixed points in the plane is a constant. Now suppose my P is moving point Z, S is suppose Z1 and S dash is Z2. Then according to this definition, what I get, the difference of whose distances from two fixed points, that is PS minus PS dash is always constant, and here this constant is again 2a, and this 2a is here length of transverse axis, and as from diagram we can see that distance between two vertices, that is 2a, that is transverse axis, and distance between two vertices is less than distance between two foci. So S and S dash are fixed points, 2a is what distance between two vertices. Now in terms of complex number, if I express this PS then this is z minus z1 whole mod minus z minus z2 whole mod, and this lambda. And lambda is here 2a, which is less than 2ae, and 2ae is what distance between two foci, that is z1 minus z2 whole mod. So here this is written that z minus z1 whole mod minus z minus z2 whole mod is constant, and if this constant is less than z1 minus z2, then locus of z is a hyperbola, where S and S dash are foci, and A is a semi-transverse axis. So this is what hyperbola in terms of complex number. But further, if my S is Z1, S dash is Z2, and P is Z, and if I express this in terms of complex number, then in this case, PS minus PS dash is SS dash, and PS in terms of complex Z minus Z1 whole mod minus Z minus Z2 whole mod is equal to Z1 minus Z2 whole mod. Then in this case, the locus of Z is again a line segment, but here Z lie outside S and S dash. So locus of Z is a straight line joining the points S and S dash, Z1 and Z2, but Z does not lie between Z1 and Z2. Now further, there is another result. If Z1, Z2, Z3 form an equilateral triangle, then in terms of complex number, my result is Z1 square. If these are the vertices, Z1, Z2, Z3 are the vertices of complex number, then in complex Z1 square plus Z2 square plus Z3 square is equal to Z1 Z2 plus Z2 Z3 plus Z3 Z1. Now here is the application which came on 2003 AIEEE exam. Let Z1 and Z2 be two roots of equations Z square plus AZ plus B, and since Z1 and Z2 are its roots, so sum of the roots is minus B by A, so here I get minus A, and product of the roots is C by A, so I get B here. Further, what is it? Origin Z1, Z2 form an equilateral triangle. So here my vertices of equilateral triangle are Z1, Z2, and Z3 is here origin. So Z3 is here 0. And what result I have, that Z1 square plus Z2 square plus Z3 square is equal to Z1, Z2, Z2, Z3 and Z1, Z3. If I put Z3 is equal to 0 here, so this comes out to be Z1 square plus Z2 square, this is 0, this 0 and this 0. So what I get Z1 into Z2. And further, I can replace this by an identity that this is equal to Z1 plus Z2 whole square minus 2Z1 Z2. On further solving, what I get, this is Z1 plus Z2 whole square is equal to 3Z1 Z2. And using sum of the roots and product of the root, I just replace this by minus A whole square and this by B. So my answer is here A square is equal to 3B. So correct option is here, option C. Here is another application. Now, a complex number Z is said to be unimodular if mod of Z is 1. Suppose Z1 and Z2 are complex numbers, such that Z1 minus 2Z2 upon 2 minus Z1 Z2 bar is unimodular and Z2 is not unimodular, then the point Z1 lies on. So we have to follow all the given condition. Unimodular means that mod of Z is 1. So its modulus is unity. And what we have to use, if we square this, we get mod Z1 mod Z square is equal to 1. And then I just replace, as we know that mod of Z square is equal to Z minus Z bar. So I just replace this mod square by Z minus Z bar. So next, this is unimodular. So I just use this given condition that Z1 minus 2Z2 upon 2 minus Z1 Z2 bar is unimodular. Same, what I do, squaring both the sides, And further I use this result that if mod z square is equal to mod z square is equal to 1, then I just replace this mod z square by z into z bar. So here this is my z. So I just replace this by z into z bar. That means I have to take conjugate. So if I have to take conjugate and conjugate using the properties of conjugate, I just replace the z1 by z1 bar. 2 is a purely real complex number. It's conjugated itself. So z2 bar upon 2 minus z1 bar, and conjugate of z2 bar is z2 double bar. As we know that double bar is again a complex number. So z2 double bar here is only z2. So this is equal to 1. Now further, I just take this to right hand side, and what I get, z1 minus 2z2 into z1 bar minus 2z2 bar is equal to 2 minus z1 z2 bar, 2 minus z1 bar into z2. On opening this bracket, what I get, z1 z1 bar minus 2 z2 bar z1 minus 2 z2 z1 bar plus 4 z2 z2 bar. On RHS, what I get, this is 4 minus 2 z1 bar z2 minus 2 z1 z2 bar and plus z1 z1 bar z2 z2 bar. Now this cancel out with this cancel out with this, and using this property again, that z bar, z into z bar is mod z square. So I can replace this by mod of z1 square. I can replace this by 4 mod z2 square. This is 4 and this is z1 mod z1 square into mod z2 square. So I just write right hand side as this. On taking all the terms from RHS to LHS, what I get, mod z1 square plus 4 mod z2 square minus 4 minus mod z1 square mod z2 square. Now further I can take mod of z1 square common from these two, and minus 4 I can take common from these two. So I'm just rewriting this, mod of z1 square minus z1 square into z2 square plus 4 mod of z2 square minus 4. I take mod of z1 square common, so what I get, 1 minus mod of z2 square, and in these two I get minus 4 common. So what I get, 1 minus mod of z2 square. Further I get mod of z1 square minus 4 and 1 minus, or mod of z2 square minus 1 equal to 0. So either this 0 or this 0, but this cannot be equal to 0. Why? Because one more condition was given to us, and that was that z2 is not unimodular. z2 is not unimodular. So this is not equal to 0. So what we get, that mod of z1 square minus 4 equal to 0, or mod of z1 square is equal to 4, or mod of z1 is equal to 2, and we know that mod of z is equal to r is what locus of z is what locus of a circle with the center at origin, and radius r. So my answer is here, this is my r, and correct option is here, option 3, circle of radius 2. I hope this video will help you to understand a lot about Locus. I'll be back with new videos. Please comment, like and share this video as much as you can and subscribe my channel method wise. Thank you.